Yes, we have been talking about the sign and unsigned case, right? There's a question as well. So what is the question? Yeah, so one student has a question. Why do we use unsigned and signed in chars? If we want to represent ASCII character, we are able to use either unsigned or signed. I mean, uh, they provide flexibility. That's all, right? So if we use if you say sign int, in that case, the sign would be considered, right? Right, like it would be. So we can assign minus values, for example. We can represent minus and plus. That means like negative and positive, both negative and positive. So, like, why we have this sign and unsigned, right? When we, as I told you, like, so we have our numbers, right? Every time, so when we are going to represent those numbers in memory, right? So in our memory, in our RAM, when we are going to represent those numbers, right? There is always a limitation, right? So for example, how many bits can be used for to represent one number? Let's say for an integer, how many bits we can use, right? In general architecture, we use 4 bytes. 4 bytes, that means 32 bits are used to represent integer. So 32-bit means there is a limitation, right? That doesn't mean, right, you cannot represent any number from let's say minus infinity to plus infinity, right? Right. We have infinite number of integers. We cannot represent all those integers in our when we are in our program. So that's why we used different perspectives, right? Like, what is our range? What is the range of values that we can represent from a value? If it is just, let's say, if it is sign, so that means negative and positive both numbers are represented. So in that case, our range would be something like this. So we have range. One part is in the negative values, one part is in positive value. We have to represent both. In some cases, we don't want to represent negative values. So let's say if you want to represent integer number, so let's say like index numbers. Let's say index numbers, student index number, index numbers. So in this case, index numbers are always positive, right? Usually we don't use negative index numbers, right? Usually starting with 1, 2, 3, and so on, right? In that case, we don't have to go for this range, right? We don't need that. So in that case, if we go for, instead of sign, if we for unsigned, then we can represent more values, right? There, without considering negative numbers. Let's say like if we have 32 bits, right? 32 bits, right? So we have 32 bits to represent. So half of these bits would be taken for negative if it is sign. So we can use them for positive if we use sign, right? Sorry, unsigned. And unsigned කියන එක අපි පාවිච්චි කරොත් දැන් අපි හිතමු signed එකෙන් අපි represent කරනවා නම් නිකන් අපි නිකන් number එකක් ගමු 10ක්. එතන ඒක double කරන්න පුළුවන් unsigned එක පාවිච්චි කරොත් you'll understand it with this, right? Right. You'll better understand it with this because so here sign or unsigned. In unsigned case, we can represent from sorry, in sign case, we can represent from minus 128 to 127. If we use unsigned, we can represent from 0 to 255. Right. So let's say like if I take this example for our, if I use these for index numbers, right? Index number represent කරන්න මේක ගන්නවා කියලා හිතන්න. So index number represent කරද්දී මම මේක නිකන් char කියලා ගත්තොත් හරි sign char කියලා ගත්තොත් හරි මෙතන අපිට මේ byte එකකින් මේ වැඩේ කරගන්න පුළුවන්. හැබැයි it is limited up to 127. Right? මොකද මේ minus මේකේ ඉඳලා මේ plus මේ number එකට යනකල් යනවා. It goes from minus 128 to plus 127. So then if I'm going to represent positive in numbers I'm using it for indices, index represent කරන්න ගන්නවා නම් I can start from 1 to 127. So that's my limitation. But if I change my data type as unsigned, then no negative values. We don't need negative values in that case. I can start from 1. 0 is there, it doesn't matter, but I can start from 1 and I can go up to 250. The number of bytes, so number of bits we use is the same, but I can get more, I can get a bigger range depending on my requirement. So is it clear why we have this sign and unsigned? It provides flexibility, so we can use them accordingly based on our based on the situation, based on the data that we are going to store. දැන් අපි store කරන data අනුව අපිට බලලා අපිට තෝරගන්න පුළුවන්. අපිට තියෙන choices. එතකොට අපිට flexibility එක තියෙනවා. මේ අපිට අර resources ගොඩක් optimum විදිහට පාවිච්චි කරන්න. We have the opportunity, we have the freedom to optimize the resources that we have. Right? So that's the thing. But in most of the cases, in general cases, in my personal experience, I don't use signed, unsigned in general program. So why is that? Let's say like, usually I use, if it is an integer number, I use int. I use int, right? It has this range of values. I can represent this range of values. Okay. Sorry, this range of value. So this range of value. This is short int. This is short int, right? It is two bytes, usually 4-byte integers. 4-byte integers. So I have this range. Most of my like my general programming, this range is enough, right? මෙන්න මේ range එකේ values තමයි ගොඩක් වෙලාවට මට මගේ programs වල තියාගන්න වෙන්නේ. මීට වඩා ලොකු values තියාගන්න. What is this value? Let's say like like 2 billion. 2 billion, right? Yeah, 2 billion කියලා කියන්නේ නිකන් අර මේ ලොකු value එකක්. හැබැයි ඉතින් මේ අපේ සමහර කට්ටිය හොරා කාපු සල්ලි size එක. Fine. In the මේ 2 billion දැන් අපි මේ ලංකාවේ මේ ආර්ථික ප්‍රශ්න ගැන එහෙම කතා කරනවා නම් සමහරලාට මේ integers වලින් අපි values දෙනවා නම් මේ integer කියන එක සමහරට මදි වෙන්න පුළුවන්. හරි. සමහර දේශපාලඥයෝ හොරා කාපු සල්ලි ගැන එහෙම කතා කරනවා නම් සමහරට මේ range එක මදි වෙන්න පුළුවන්. ඒ වුණොත් then we can go to this long int, right? Long int. So they have like and then actually so there are several yeah, I mean usually so in that case we can go for unsigned, right? So then we have the double the range, right? So likewise, I mean, so we can depending on the situation, we can select what data type we use. Okay. So there's a question: should we memorize all these? It's up to you. If you want to memorize it, you can memorize it. If you don't want to memorize it, that's also fine. But you should know how this value came, right? So who's this student? 874. You have to identify what this value is. How this value, right? So do you understand what this value is? Each of these value. So that's all. I mean, if you understand how this value so what is this range? What this range is, so that's all, right? So let's go with you. So can you tell me why this is 65,532? Sorry, 35. Why this value? No, I mean, I'm asking why this value? Why this value? මේ value එක වෙන්නේ මොකද? මේක 65,535 වෙන්නේ. 36 නොවි, 34 නොවි 35 වෙන්නේ. Yeah, exactly. Right. Like it is like we already discussed these things. Huh? Right. It is how many bits available? Two. 2 bytes. That means 16 bits. 16 bits. So then, how many numbers we can represent? How many different numbers that we can represent from 16 bits? 2 to the power 16. Right? So then 2 to the power 16 means we can represent those numbers in anywhere. Right? Right? From 0 to somewhere in our number system, or we can represent some negatives and positives as well, including 0. Right? So in that case, so let's say like here, if we represent only positives, like without considering sign, so then it is, you have to calculate this value, and then with 0, right, we can get, you will get that value. Right? So that would be the maximum value that you can represent. Right? So if you know that, so then that's fine. Right? You have to understand these values. That's so. Right? In unsigned case, definitely it is 4 bytes. So that means 32 bits. So 2 to the power 32 minus 1 has to be this. Right? Okay, right. So now, for integers, it is fine, right? For integers, it's fine, right? But in float and double with decimal points, right? I briefly discussed that as well. In floating point representation, so we have a different way of using our bytes to represent a floating point number. So we have like set of bytes are allocated, right? So usually, like in general case, it is 32-bit, 4 bytes, right? So we call them 32-bit single precision floating point representation, right? So there, these 32 bits are divided into 3 parts. 3 parts. Right? When it comes to a floating point or the decimal point number, so there are, we can represent it in a standard way, standard format, right? So in the standard format, we have a fraction, an exponent, and then radix or r, right? So we can represent it as this: f multiplied by r into e. Right? So in that case, if we say like exponent, right? Exponent is represented using 8 bits. Right? So we have sign bit, plus or minus would be decided by this. If it is 0, it is plus. If it is 1, it is minus. Remember that, right? Not the other way around. If it is 1, it is minus. If it is 0, it is if it is 0, it is positive. If it is 1, it is negative, right? Then we have another 8 bits for the exponent part, right? And then the rest of the 23 bits are used for the fraction part. So usually, like we represent it as, like, let's say 2.5 multiplied by. So usually, like in a standard way, we use E, right? Then we have fraction here. Let's say any number here, right? Exponent. So this is the exponent. So this is the fraction, and so radix here, right? So we just represent these two in our number. That's all, right? So this is the exponent, and this is the fraction part. Then the most challenging part of the decimal points is, like we cannot represent all the values, right? So that's the thing. We cannot represent all the values. As we discussed last week, like let's say between 0 and 1, how many numbers are there? Infinite numbers are there. So we cannot represent all these numbers, but only some of those numbers can be represented using our limited set of bits, right? So for some values, we have to get its closest representable value, right? In that case, when you are doing some calculations using the floating point numbers, there would be some strange mismatches, right? It could happen. It is very, very it's usual in programming, because but you have to understand, right? You should know that these problems could occur. So based on that, you have to prepare your programs, right? So basically, that's what we have been discussed. I took some time to remind you of those things, because because we could continue our discussion on those things properly, right? But here, so in this slides, I have given some programs. Today, I'm not going to do those programs, but in the next practical session, let's try to do some let's try to write some programs based on these concepts. Okay, right? So then the next part. Today, actually, I have been planning to go to the next part, which is lecture 4 set of slides, the operators. Right. So let's move into that one. So basically, so data representation, right? Data representation and operators. So these are so these concepts go together, right? So I told you, like in our programming, when we are writing a program, what we do is we process data, right? We process, we do something on data, right? So that's why I wanted to first discuss the data, right? We do something on data, right? And then operators would decide operations. We do something on data. That something is decided by operations, right? Right. Data කොහොමද represent කරන්නේ? Data වලට මොනවද කරන්නේ? What we do on those data, right? So in this session, we are going to discuss these operations. So those operations are handled by operators. So there are multiple operators in any programming language. So let's see what C provides us, right? With to work with our data. Right? C operators. An operator is a symbol that tells the compiler to perform a specific mathematical or logical function. Right? It is a symbol. It's just a symbol. It tells the compiler to perform something on our data. Right? So there are built-in operators in C language. So we can categorize them into several, mainly 6 types, 6 categories. 6 categories of operators are there. Arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, and miscellaneous operators. Right? So that means the other operators which are not belong to any of these categories. Okay. Right. So let's go through one by one. These are not difficult. You already know these operators. But when it comes to the language, sometimes, so those symbols, the way you are using those symbols are different. Right? So when I introduce those things, don't just say මේ සමාන කිරීමේ ලකුණනේ මේක අපි ගන්නවා මේවා ඉගෙන ගන්න දෙයක්වත් නැහැ. එහෙම කියලා කියන්න පුළුවන්. හරි? හැබැයි මෙතන මේ like you may just say like, so those are mathematical operations, we do already know that, right? But please remember, this is very serious. Mathematical operators and programming operators are totally different, right? So you will understand. If you don't know that, you'll understand that, right? In mathematics, right? So we use, this is a one operator that we use in mathematics. It is the equal symbol, right? But in programming, this is not equal. This is not the equal symbol. I'm not saying just general programming, C programming. So this is not equal. We don't call it equal, right? The equal කියන නමවත් අපි මේකට පාවිච්චි කරන්නේ. This is the assignment. assign. This is the assignment operator in C program and in most of the other programming languages. In C programming, equal means this. Right? So remember that if you write this one, when you have to write this, the program is incorrect. It is a not a complete program. You will get 0 marks. Right? So that's the thing. So that's it is that serious, right? Okay, චත්තම serious කතාවක්. ඒ හින්දා මේ operators කියන මේවා මේ දැකලා තියෙනවා කියලා එහෙම ගන්න එපා. ඒක මේ හරියටම මේ programming context එකේදී ඒක ඔළුවට දාගන්න. Right? You have to think in the programming context, and then you have to rethink about these operators. Okay. Right. Okay. So let's go through one by one. First, arithmetic operators. So arithmetic operators are 4 arithmetic operations. What are arithmetic operations? Addition, subtraction, multiplication, division, and several others. Right. So these are general operators. Right? So then in C programming, we use plus symbol for the addition. For subtraction, we use minus, same as mathematical operation. But for multiplication, right? So we use asterisk for the star symbol, right? In your programs, if you write this for as multiplication, so it is actually wrong, right? It has to be this asterisk. And then for division, we use this, right? Yeah. So those are not much difficult, right? Then, so we have another 3. This is modulus, and then increment and decrement. Can anyone tell me what these 3 operations are? Oh, these operators are. Right. So until you tell me, let's go with our general operators. So if I take addition operator, so I can use that addition operator with two values. Right. And the other thing is, let's talk about that as well. Like when we talk about operators, right? So we have operators and operands. Operators and operands. Operands. Operators are the symbols, right? Let's say addition. Operands are the ones, the things that we do this operation on, to whom that we apply this operation. operators. මේ කාටද මේ operation එක කරන්නේ? Operators apply කරන්නේ කාටද? To whom? To whom we apply the operators. For example, like, so if we say 1 plus 2, so here, this is the addition operator, so these are operands. So operands are the subjects of this operator. Right? So in this case, we can identify two types of operations based on the operands, right? Binary operators, and unary operators. Binary and unary. Binary means those operators needs always need two operands. Like our previous example, addition operator. Addition operator needs two operands, right? Add කරන්න නම් දෙන්නෙක් ඉන්න ඕනේ, right? With one operand, we cannot do addition operation. Right? With one operand, we cannot do, right? So it is like to make a baby, there should be a man and a woman. Now there are some other medical treatments and there are medical ways of doing that. But anyway, like so there should be generally there should be a man and a woman. Likewise, like there should be two operands, right? Addition, subtraction, even multiplication, division. For all these operations, we need two operations. So we call them binary operators. But there are some operations, some operators we call unary. So in that case, needs one operand. One operand is enough, right? So to make a baby, there should be a man and a woman. But to drink a coffee or something, we don't need that, right? Like just you can drink that by yourself, right? Right. Okay. So we have binary and unary based on the number of operands involved. එතෙන්ට set වෙන operands ලා ගාන අනුව අපි decide කරනවා මේක binary ද unary ද කියලා. So we can decide that later on, right? Okay, let's see. So we have this division as well. I just introduced that. Okay, so let's go through. Okay, so we talked about these four, and then I asked you modulus. What's the modulus? So let's see the answers. Modulus give the remainder. Exactly. We call it modulus as well as remainder. Modulus or remainder. Right. So the symbol we use is the percentage. So in mathematics, this could be percentage, but in programming, this is modulus. Right? So here, the idea is so the idea here is if we take two numbers, right? Right. If you use division, let's say division, right? So the one thing, the modulus and division, they are very close, right? Right. Let's say 2 divided by, sorry, 10 divided by 2. What is the answer here? This would result 5, right? So let's say, right, 12 divided by 2. Again, will give 6. Let's say 15 divided by 2. What would be the answer here? 7. But here there's a slight problem, because 15 divided by 2, usually, the answer has to be 7.5. Okay. But the thing is, it depends on how we consider. Like, so this is a floating point or with decimal points. So this would be the answer. But let's say as an integer, if we want to get the answer as an integer, so then it will give 7. Then actually 7 multiplied by 2, it would be 14. So 1 is remaining. Right? 1 is remaining. Right? This is divided into 7 and 1 is remaining. Right? So this remaining value, right? when we when we are little, like we used to divide like this, right? So 15 divided by, the answer is 7, and then 1 is remain. Right? In our integer division, right, this would give as the answer if it is a division operator. But instead of division, right, now I'm going to do something very, very strange. Instead of using division, okay, let me do. Okay, so let me do like this. Okay, that's fine, and then right. Okay, so now instead of using division, if I use modulus, it will give 1. If it is division, this one would be the answer. This one would be the answer. If it is modulus, this one would be the answer. 15 division 2, 7. This one would be the answer. 15 modulus 2, this one would be the answer. That's all. So the remainder would be given in modulus. It would divide by this value, and then remainder would be returned. Remainder would be given as a result. Right. I think it's clear, right? The difference between modulus division and modulus. Let's say, let's get some other several examples, like let's say 500 modulus 100. What is the answer? Yes, exactly. 0. Because no remainder. So let's say 500 modulus 200. Yes, the answer is 100. So let's say 500 modulus 300. 200. Let's say 500 modulus 600. Yes, 500. Why is that? Because 500 divided by 600. So it is 0, and how 500 is remain. 500ට 600 බිඳුවයි 500ම ඉතිරි මේ 500ම ඉතිරි. So 500 modulus 900. Again the same 500. Right? Yes, okay, right. Now you got the idea, right? It's a remainder. It's a remainder modulus. So modulus is very important in programming. For example, one particular example is if you want to check whether like divisible බෙදෙනවද නැද්ද කියලා බලන්න. It's very, very important. In many, there are many such operations are necessary in the program. For example, odd and even. Right? If a number is odd or even, right? ඉරට්ටේ දොත්තේද කියලා බලද්දී දෙකෙන් තිරි නැතුව බෙදෙනවද නැද්ද? Okay, we have to check that. Right? When you check the divisible, right? And then when you check the limits in some data structures, some collection of data. So you use this modulus a lot, right? So let's see how they are used later on, right? So anyway, modulus. Okay. Again, modulus is unary or binary. Modulus, is it unary or binary? Is it a unary operator? It's binary. We need 2, right? And the other thing is, there's a very good question here, right? Like someone student asked, modulus work with only in data type. So that's another, again, another concept, right? Like when we talk about these operators, with operators, there are some limitations are introduced, right? So, for example, one very strict rule that we use. So modulus can be used only for integers, right? If these A and B are integers, then only we can use modulus, right? For division, we don't have that problem, or any of these previous operators, we don't have that problem, right? So you can use, for example, 2.56 plus, you can use this statement in your program, no problem, it is fine. If you have 2 variables, int A or int B. Right. You have two variables. Right. So we can use this kind of statement. Whether it is integer or if it is float, whatever, you can use. But for modulus, your operands must be integers. Integers වලට විතරයි modulus එක දාන්න පුළුවන් එච්චරයි. Right. Okay. So now we have 5 operations or operators, 5 arithmetic operators, right? And then we have another 2 operations or operators, which are unary operators, increment and decrement. So that means for increment and decrement, we don't need 2 operands. 1 operand is enough, right? So let's see what is increment and decrement. It is very simple. Increment operator increases the integer value by 1. Again, you can identify, specifically mention integer value. So the increment operator can be applied only for integers, right? Decrement again for integers. We can increment or decrement the value, right? Suppose if we have value, right? If you use increment operator, it will increment the value of A, this variable, by 1. Decrement again, if it is A minus minus. In this case, increment, decrement by 1. Value එකකින් අඩු. For example, A plus or A minus. There's a question, what is the flow division operator in C? Actually, division, I'll mention that as well before going to the increment and decrement. In division, right? So usually, right? So the like in mathematically, the answer would be 2.5, right? But if it is an integer, right? Right. If we want to represent this as an integer, right? You can give this in a different ways, right? One way is, right, like 2. Without like just ignoring this 5.5, 2. Because so this is in between like 2 and 3. This is in between this, the middle. So you can say it is 2, or you can say it is 3. Right? If you want to represent this as an integer. So in this case, like even in mathematics, we have that concept. We have two values, right? We consider this one as the flow value, and this one as the ceiling value. Ceiling. I'm not sure exactly the spellings, right? But ceiling value, upper value and lower value. Flow. Sometimes we call it the roof value. This one, right? But in programmatical context, we use a ceiling. That word. So when there's a division, right? Sometimes if you want to get the output as an integer, we can use these functions. But these are not operators in C. We don't have operators, specific operators for these, right? But in some other languages, right? So they have special functions to get flow and ceiling, right? They have special functions to get the flow value of a division and ceiling value of a division. Right? So if I take these operators, these first two, those are not much of a trouble. And then multiplication, even multiplication is not a big trouble. But division, you have to be very careful. You have to be very careful. So even in multiplication sometimes. So you have to be very careful when you use that. What are the numbers? Like integers or floating points, the data types that you are going to use there, those are big concerns, right? ඒවා හරියට data types මෙතනදී මේ පොඩ්ඩක් mismatch අර එහෙම වුණොත් එහෙම එන උත්තරේ බලාපොරොත්තු වෙන එක නොවෙන්න පුළුවන්. right? ඒ හින්දා මේ division එකේදී මේ හොඳට බලන්න ඕනේ modulus එකේදී ඊටත්. So you have to be very careful in the modulus. Right? Okay. So then let me go to the increment and decrement. So increment and decrement, it is very simple. The idea is very simple. Right? So we are here. The value of A is incremented by 1. Right? So let's say, like, suppose we have a variable in our memory, right? So the variable A. Suppose this is where we are going to store our variable. So let's say in our program, if I say int A is assigned with 10. Right? So now I have value 10 in this variable. Then if I say A increment. This is unary. I can just use this operation only on A. So then this is correct, and it will operate on A. Go to A and take the value and increment the value of A by 1. Increment the value of A by 1. So how to increment? It will take the value 10 and then increment by 1. What is the answer? 11. And then put that value back here. And so now the value would be 11. Increment by 1. So that is the increment. There's a question, so can't we use char with plus operator? You can. Char data type, right? As I told you, char data type can be used as an integer as well as, actually inside, right? When the actual data representation is there, char is represented as an integer, a number, right? So that's why we have ASCII values, ASCII table, because the ASCII value is a number which is stored on a memory as char, right? एक character එකක් විදිහට දෙද්දි විතරයි මේ ASCII table එක පාවිච්චි කරන්නේ. The ASCII table is used to convert it into the character representation. So otherwise it is a number, right? If it is a number, you can use all those operators, plus, minus, like addition, subtractions, without any problem. You can treat it as a number. Right? Is it clear? Right. Right, okay. So now, so the increment is something like this. So let's say in the next line, right? Suppose this is the first line of my program. This is the next line, right? And the next line, right? So let's say in the next line, if I say A decrement. So this is the semicolon, huh? Semicolon. It's the semicolon of my program. This is the semicolon. Right. So now, so we have originally it was 10. We incremented it by 1. In the next line, if I decrement it, so then actually A minus minus, get the value of A. Get the value of A, it is 11. Decrement by 1, 10. Answer would be 20. Now again it will be, the value would be 10. Right? Increment and decrement. But when it comes to increment and decrement, we have 2 types of increment and decrement. Right? Pre-increment. And post-increment. Pre-decrement and post decrement. So post decrement means this operator comes after the operand, right? Like A plus. Post decrement means A minus. However, right, we can put this operator in front of the operand as like this. A plus plus can come here. Minus minus can come here. This is called pre-increment and pre-decrement. Which side of the operand? Left or right? If it is left, so then it's we call pre-increment. Otherwise, we call post-increment. So increment and decrement, there are two types, right? Pre-increment, pre-decrement. Post-increment, post-decrement. So what is the difference between pre and post? What is the difference? There's a big difference. Actually, like even pre-increment, pre-decrement, post-increment, post-decrement, both do the same. Right? Increment by 1 or decrement by 1 in both cases. However, with the pre or post, the results would be different. So actually next in the next session, I'm going to discuss this. But if you have time, just check what is pre-increment and post-increment. So in the next session on Friday, so hopefully I hope there won't be any power interruptions or any other problems. So I'm planning to do a practical session with the data types, and then with some data representation concepts, and then with initial operators, right? Especially arithmetic operators. And if we have time, let's go to other operators like relational operators and so on, right? So anyway, please go through these slides. What are the available operators that we have, right? So we will further discuss those things in the next session, right? Because like today, like we have another 5 minutes or so, we don't have enough time to discuss that concept of the pre and post increment, right? And the other thing is, if you have questions, you can ask, but I have an important sorry. So I actually regarding the project groups that you have, right? So I hope you have created your groups for like this week. I will provide you on LMS. I will provide you a link to upload your group members. And then by next week, we can finalize all those group arrangements, and then we can start discussing your project ideas. And then we can, soon we can have a presentation for each group to initiate the programming project. Okay. So keep that in mind. I will maybe today or tomorrow I will open a link to submit your group information. Okay. Right. Any questions? Any questions before concluding the session? So please go through these slides, all right, operators, and we can further discuss. Right. Okay. So then see you on Friday, usual time 10:15 for the practical session. So if you have any questions, you can contact me anytime. And sorry, there was one question from one student about a program. So because of my health problems, I couldn't look into that. So I'll soon reply to those problems in the programs. Right. Okay. So thank you, and stay safe. Have a nice day.
Thank you, sir.
Thank you, sir.
Thank you, sir.